Okay, we're going to graph the function natural log of x, which is usually written ln and then parenthesis x. Okay, so this is kind of a difficult function to understand. It's certainly one that's hard to evaluate by hand, so typically you'll always use the calculator when you need to put a number in for x in the natural log function. And by the way, to do that, if you want to compute something like natural log of 5, you just on the calculator hit this ln button. Okay, on the screen that'll put something like ln parenthesis on the calculator. Just type the number 5 and put a in parenthesis here, and then press enter, and there you go. So pretty easy function to put numbers in on the calculator. Okay, so let's go ahead and do this. Well, we need to plot some x and y pairs in order to get a good graph of this function. So I'll start by picking some nice positive numbers for x. Okay, if x is 1, y is going to be the natural log of 1, which turns out to be exactly 0. Okay, so the point 1 comma 0 is on the graph. Okay. If x is 2, y is going to be natural log of 2, which is about, let's see, it's about 0.69. So when x is 2, y is about 0.69, something like that. When x is 3, natural log of 3, it's about 1.10. Okay, so I've got the 0.3 comma 1.10 on the graph. And I can put 4 in here too, but just to go a little bit further to the right, maybe I'll put a bigger number like 7 in. So when I put 7 in for x, I get natural log of 7, which, let's see, it's about 1.95. Okay, so 1, 2, 3, 4, 5, 6, 7, comma 1.95, just right below 2. Okay, so I just picked a few values, increasing positive numbers here, and you see that the natural log function is growing to the right, but pretty slowly. Okay, now normally I might put in other positive and say other integers, maybe some negative integers and 0, but if you remember, we said in the notes that natural log is not defined for numbers that are less than or equal to 0. Okay, so natural log of x only makes sense when x is positive. And I might just say a word about that. What that means is that I can't take natural log of -2, for example. And the reason for that, you might remember in the notes we had a little statement about this. The rule is, this is the inverse of the exponential function base e. So if I ask you, if I call this number y, okay, what is natural log of -2? Well, that's the same thing as asking e to what power is -2. Okay, and you can't raise a positive number to any power to get a negative number. Okay. Right, that's the equivalent statement for the exponential function base e. Okay, so since this doesn't have a solution, this doesn't make sense. We can't take natural log of a negative number. We also can't take natural log of 0. If I asked you what natural log of 0 is, I'd be asking you, what power of e gives us 0, and you can't raise a positive number to a power to get 0 either. So we can't put any negative numbers in for x or 0. Okay, and by the way, that really tells us something we'll notice on the graph. If you were just to graph this on the calculator, the domain of natural log of x is from 0 to infinity, so numbers bigger than 0 to positive infinity. Okay, on this graph you're only going to see x coordinates which are positive. Okay, so we can't move to the left of the y-axis to graph the function because there is no graph there. But we could put an x value in which is between 0 and 1, and we might do one of those. If I put a really small positive number in for x, like 0.1, I could go to the calculator and find natural log of 0.1, and that actually is defined, and it's about -2. Let's say 30. Okay, so when x is 0.1, just a tiny bit to the right of the y-axis, y is -2.3, which is about down here. Okay, so if I connect these dots, the shape of the natural log function, again, it's a little difficult to connect them on my handwriting utility here, but try that again. Well, we get something kind of like this. Okay, Well, that's not too much better, is it? Okay, but you can see this one graphed in the book. Yeah, I gotta do better than that. Okay. Okay, well, that's not too bad. What you'll see is that the function increases to the right. In fact, it's always increasing. It's moving further up as we go from left to the right. And to the left of the x-coordinate of 1, the graph moves down below the x-axis and gets closer and closer to the y-axis. So the range, which remember is the set of all y values we find on the graph, is actually everything, negative infinity to infinity. Okay, we can get any y value out, a very large negative number, or a very large positive number if we move to the appropriate x-coordinate. Okay, but that's the basic graph. And again, if you want to see a slightly better drawn version, you could always go to the calculator. And again, there's really nothing to doing that at all. As always, if you want to graph something, you just hit this y equals button, and you'll get to that equation editor menu, and just need to type one function, hit the ln button again, and place an x in there, and then hit the graph button on the top row there, and you can graph the function natural log of x. But of course what you'll see is a slightly cleaned up version of this graph. Okay.